So in this example, we're going to look at some specific inputs and outputs of the operational amplifier. I have to tell you that the configurations we're looking at in this example are very simplistic, and we would almost certainly never use these in a real-world circuit, but it's the first step toward the real-world circuits we're about to consider. So in part A here, you can see that the two inputs are very close together, 2.500 and 2.501. We see the positive and negative power supplies are indicated here. As I mentioned before, these are not always shown in the circuit diagram, but they are shown when they're important, and they are important in this case, so I've included them. And our purpose here is to find V out if the gain of the circuit is 5,000. So we know that there is really one equation that we're going to be able to use for this calculation, and that is that V out is equal to A times V plus minus V minus, which in this case, that is 5,000. By the way, just a moment, 5,000 would be a very low overall gain for an operational amplifier. I've chosen this number to make the problem work out well, but just be aware that 5,000, that would be a terrible op amp. You would be wanting to see something more like 500,000 or 1 million, but that makes the problems that we're looking at here not useful. So I've intentionally chosen some smaller values for this problem. In this case now, V plus, remember that the plus sign here is going to indicate the V plus. So this is 2.501 minus V minus, that's the one that's attached to the negative sign, 2.500. And therefore this is 5,000 times 0.001 volts. And therefore this is 5 volts. So the output of that op amp would be 5 volts given the configuration we have here. Let's just double check. We know that that voltage cannot be higher than the positive supply, nor can it be lower than the negative supply. 5 is less than 10, and it is greater than negative 10, so this is fine. So that's part A. Part B, analyze this op amp circuit and determine the output voltage. The gain here is 10,000. Okay, so we're going to again see that V out is going to be the gain, 10,000, multiplied by the positive voltage, 2.500, minus the negative voltage, 2.600. I should say the voltage at the inverting input. It's not the quote-unquote negative voltage. It is at the inverting or the negative input here. So V out, in this case, is going to be 10,000 times, and this is a smaller number minus a larger number. There's nothing wrong with that. We've known how to do that for quite some time. That means that this is going to be negative 0.1 volts. And therefore, V out is negative 1,000 volts. And that's what our equation shows us, but we know that that's not valid. So negative 1,000 is less than the negative power supply here, negative 12 volts. So V out is going to be limited by the negative supply voltage, and therefore it is going to be negative 12 volts. That's actually very important. The fact that it can't go higher than the positive supply nor lower than the negative supply is something that will need to be considered in almost every op amp problem that we're going to talk about. And then what is the voltage in this circuit if, the voltage V plus. So now one of the input voltages is unknown. We know that the gain is 1,000, and I know that the output is 11 volts. Well, V out is equal to A times V plus minus V minus. In this case, 11 volts is known. This is equal to 1,000 times V plus is the unknown. V minus is 5 volts. One equation, one unknown, so I can see V plus minus 5 volts is equal to 11 volts divided by 1,000. This works out to be 0.011, and therefore V plus is equal to 5 plus 0.011, which is 5.011 volts. So something to think about especially in part A and in part C. Remember that up in part A, those two voltages were very close together, 2.501 and 2.500. And then down here in part C, Although we didn't know it at the time, this is 5.011 volts, so those two voltages are also very close together. What you're about to learn is that these two voltages at these two inputs always have to be very, very close together unless the voltage at the output is going to saturate. Usually we're going to say that the voltage there isn't going to saturate, so we're going to know that these two voltages at the inputs are going to be approximately equal to each other. That's something that we'll talk about in the lesson, and you'll see in the future applications. But for right now, we've seen a few examples, and we can begin to see that those two voltages need to be quite similar to each other.